Hi guys, so welcome you all to the another GBO Tech Talk session. So I'm Tarindu. So today I'm going to talk about the Azure SignalR service. So since this is our first online Tech Talk session, so I would like to share you the quiz link. You guys, okay? Sorry, I haven't started that yet. So I can. I'll copy this and I'll put it in the chat of this meeting. So if you find out that you need to have ask a question, you can just ask it and notify me via this link. So okay, how can I get rid of this one? Okay, I think it's going to be there, I think. Okay.
So Tarindu, have you just shared the entire slides or is it just the link for questions?
Just the link for the questions.
Okay.
Okay. So guys, so then start the Tech Talk session. Okay, so I'm going to talk about the Azure Signal Service. So before moving to the Azure SignalR Service, you should have some idea about what SignalR. So what SignalR is basically. So probably I think that most of people here in GBO is familiar with this SignalR concept. Even Adip and some other person in very all the time have done some tech talks regarding SignalR. So I was able to find out those things. And but since there are some new faces and some of them might not have worked on SignalR, so I thought it's better to have a quick understanding about what SignalR is. So SignalR is mainly used in real-time web functionality. So suppose if you have some scenario like to send some data very frequently, and also if you have some scenarios like if you want to send some data directly from your server to clients, because we know that normally we are used to implement the methods that which is called by clients in the server. So we just do the request and get the data as the response. But if you want to do it more frequently, you might need to do the polling. So, but without the polling, if the server can just send the request response whenever there is update onto that particular entity or some other thing, so it will basically save a lot of API calls which you are going to generate from the clients using polling techniques. So that's because of that. So SignalR is common in chat applications and dashboard and monitoring applications, and also some applications which use GPS and maps. So that's the basic. That's the main common features of the signal usability of the SignalR. So let me now talk about how the SignalR works. So as I previously mentioned, so when you want to get some update data frequently, we are going to use the SignalR. So if that's so, when we are doing polling, what we do is we call the server from the client and then ask the response. But since SignalR is not going to do that, it's just do the sending data from the server to client. But actually, in the behind the scene, how SignalR works is kind of similar to that polling mechanism, but not 100% polling. So we call that is remote procedure calls. So it's not a polling, but it just invoke the other entities, other components method via this protocol. So if you can see this diagram, so I have in the first diagram, so I'm going which is describing how it's SignalR invoke client methods from the server. So basically, when server wants to send a message to the client, so the server is going to invoke a method using remote procedure call, invoke a function using remote procedure calls in the client side. And also vice versa, when client wants to send a message to the server, the client will invoke a function using the protocol. So that's what actually happening inside the SignalR. So to handle this connection, this communication, SignalR basically works on 3 different communication protocols, basically using the WebSockets and the server-send events and the long pollings. So the most common usage of technology is the WebSocket, because if the clients are available to communicate via WebSockets, then SignalR will always use WebSockets. But if the client is not available with WebSockets, then it will fall back to the other communication protocols which mentioned here, like server-send and the long polling. And so I have also mentioned these hubs relating to this SignalR, because SignalR, so if you can see this diagram, you have seen that there's this hubs concept. So actually when I was doing the first research on SignalR, so I was a little bit confused with what this hub means. So even I had discussion with Hiran, yes, so I was confused a lot of times. So then finally we were able to identify that. So this hub is the main communication pipeline between the client and server. So that's the high level explanation which you can see in the documentation. But what actually hubs does is, so it exposes methods, functions to invoke from the other entity. So I will demonstrate it in the my demonstration. So you have to have some hubs in your server implementation in order to get invoked by the client's application. So yes, I will. I'll just describe it like that for the moment, but I will show you the hubs and how it works in the my demonstration. So moving on to the next. So actually there are 2 versions of SignalR at the moment. So the first version is the ASP.NET Signal, which is the oldest one, and the new one is this ASP.NET Core SignalR. So there are some differences, so which I have mentioned here, like the .NET Framework and the support of the .NET Core, and some of the features are inbuilt available with .NET Core SignalR is basically available with the main SDK, but .NET SignalR is not available. You have to use some other packages. So, and some of the connectivity configurations are different, and also that the other main difference is that how those 2 versions handle the connections between the hubs in the system. So yes, so those are the main differences. So since I have mentioned this multiple hubs concept in the in this difference in here, so I would like to express it. So since I mentioned you that the hubs are the main thing that expose the methods to invoke from the other entity, other component basically. So if you have a large application, so there's going to be more than one hub. So if you have some application like you have one component which is mainly dedicated for chat and communication in the application, and one thing is for monitoring dashboards related things. So then you can have 2 separate hubs in order to communicate via the SignalR, because it will increase your throughput, since hubs are going to have persistent connections. So if you have multiple hubs, so then it will have multiple connections. So in a way, it will increase your throughput. So that's what happening with this multiple hub concept. Okay, so here are the basic earlier versions of the SignalR. So for the time at this moment, so for the time being, I have talk about only the two different versions of the SignalR, but then I will move to the actual thing which I'm going to talk today. So which is the Azure SignalR Service. So previously I have talk about the basics behind the SignalR. So the SignalR Service is a Azure managed service built on top of the ASP.NET Core SignalR. So that's what today I'm going to talk about. So as I mentioned previously, so it is an Azure managed service. So now you can think that so there's going to be two SignalR implementation. Like one is going to be Azure managed implementation, and one is going to be self-managed. So it's called self-hosted SignalR. So basically the previous versions of the SignalR, so whether it's ASP.NET SignalR or ASP.NET Core SignalR, it's just a matter of implementation using the frameworks. But if you use that without SignalR service, your SignalR hubs and the servers are going to be run with your application server. So basically your web app and the SignalR hubs and servers, basically SignalR hub servers we call that, are going to be inside one place. So what happens is when a client is going to communicate with the web application, and also it needs to communicate with the SignalR, it directly communicates with this one entity. So as I mentioned previously, SignalR is using persistent connections in order to do the communication with the clients and also with the server if the SignalR is in somewhere else. So that's what SignalR Service. So basically, it will have persistent WebSocket connections with the clients. So if that's the case, so if there are multiple clients connected to this web server, so then there will be a lot of persistent connections into our web server. So it is kind of problematic because it will lead to some kind of exception in future, like socket connection limitation, because of the socket connection limitations available in one environment. So yes, that will be more problematic with the lot of persistent connections. So, but when it comes to the Azure SignalR service, so the SignalR service is managed by Azure and it rests in one other place than our application server. So the our clients can basically communicate with our web API as the usual way, but it's not going to have any persistent connections with our web application server. So, but it's going to have the that persistent socket connection with the SignalR service. So that's not going to be a problem for us then. So that's going to be a problem for SignalR service, do whatever the management things which it has to do in order to handle those multiple connections. So now our service is kind of okay and kind of not problematic with the socket connections. So that's what the basic behind the SignalR service. So it's managed by Azure and it's in some other place. And the clients are communicating with the SignalR service directly with persistent connections, web sockets basically. And our web service is going to communicate with the SignalR service with fewer number of persistent connections comparing to the client connections. So we call these connections between the client and the SignalR service, it's client connection, and the SignalR service and between SignalR service and our web application, we call it server connection. So moving on. So why Azure SignalR Service? So it's basically of the simplicity, because we don't need to worry about the availability of the SignalR service, scalability, and the performance of this, because those are available with the service level agreement. And if you want to manage your own SignalR service, then it will be a problem, because you have to think about the availability of the SignalR service as always, and the scalability, and also going to be a performance hassle. And the next thing is, yes, as I mentioned, so you no need to worry about handling large number of persistent WebSocket connections. So our web service now not going to face any problems with large number of persistent WebSocket connections. So because this has been handled by the SignalR service. And the one other major thing to use this Azure SignalR service is the support of the serverless implementation. So with the Azure, with the ASP.NET and ASP.NET Core SignalR, so that the serverless implementation is not supported. But when using the Azure SignalR service, so the serverless implementation is supported. So then your self-hosted one. So moving forward, so okay, so previously I mentioned that the SignalR service is built on top of the ASP.NET Core SignalR framework, but it is supported by it also supports the ASP.NET SignalR by doing some re-implementation to their data protocol. So in a way, even if you have a very old SignalR system implementation, which is relying on ASP.NET SignalR, you can come to work with the SignalR service by doing some small modification. So if you have even if you have a self-hosted SignalR course implementation, then also you can quickly move it to the SignalR service without a lot of hassle. So that's one major benefit which you are having with the SignalR service. So okay, so here, so you are seeing that the internal, that normal high-level architecture of the SignalR service, so which I have already mentioned a few times back. So, but there are some other things which I need to explain here. So as I mentioned, so our app server and the SignalR service is going to be in two different places. In order to have the communication, our app server is going to have persistent connections with the SignalR service, but it's in small. It will be a very small number, like 5 connections per hubs. And for the clients, clients can directly communicate with the SignalR service with a persistent connection, and that's usually enough to do the communication. So client can directly call the SignalR service, and it will via the clients can directly call the app server via the SignalR service in this method, in this way, and vice versa. App server can send message to the clients via the SignalR service using these client connection and server connections. But due to the security reasons, so we don't need to expose our SignalR services endpoints in order to do the client communication directly from the client. So that's what SignalR service suggests. That's why SignalR suggests this negotiation protocol, where you need to get all the SignalR resource endpoint URL and the access tokens in order to do the communication between the client and the SignalR service. So basically, all the SignalR services are service implementations are using this negotiation call request from their clients to the normal app server as a normal HTTP call in order to request those information in order to initiate the connection between the client and the SignalR service. Okay, so that's about the basic architecture, how that communication happens in the SignalR service. Okay, so I have here explained a few other things regarding the client connections. So first send a negotiation request to the application server, and then connect to SignalR using the URL and the access tokens from the negotiation response. And when talking about the server connection, so once the server started, so basically that's going to create 5 WebSocket connections per each hub with the SignalR service. So app service is going to create 5 WebSocket connections initially. But if you think that if you want more throughput by having more than 5 connections, you can just configure this value to a higher number like 10 or 15 in the configurations. So yes, and sorry. And one more thing, so the message sent from clients from the clients to the server will be multiplexed into this small number of connections which you are having between the server and the our Azure SignalR resource, SignalR service. Okay, so the other point is, okay, how can I get rid of this? Okay, so the other point is, if the client connections so if the server connection gets disconnected, basically the connection between the app server and the SignalR service get disconnected, all the client connections that are served by this particular server connection will be closed. So basically, client can then cannot communicate with the SignalR service because those connections will be closed by the SignalR service automatically. So that's the basic behavior. So with the SignalR service, so I will show you that so there's going to be some service modes. So there are some service modes available in the SignalR service. So basically there are 3 service modes. The first one is the default, serverless, and classic. So I'll explain like this. So default is the normal scenario which we are going to use the SignalR service when you have your own server application, and if you can host your hub servers, basically not a host kind of thing, it's just if you can run your hub codes in your server, so basically we called it a hub server, then you can just use the default mode of the Azure SignalR service. But if you think that if your implementation is serverless, so you don't have a way to have this hub service. Okay, so then the SignalR behavior is a little bit different, because if you can remember this particular diagram, so in order to do the communication, there's need to be hub server. So if hub server always running, but but the serverless applications are run on demand, so it's not going to be continuously running. So then these server connections cannot be maintained for a longer period because it's basically run on demand. So then it's going to be a little bit different than how it works on the default mode in which we have the hub server. So because of that, so it supports these both 2 different modes in the Azure SignalR service. So it is default and the serverless. So if you want to use it in the serverless implementation, you just need to check it. So I will show you where you can change it. And the other mode is the mixture of these 2 modes. So, but it is not kind of recommended because it is kind of problematic. I explain it. So if you want to use this classic mode, it means that you have an implementation which is partially serverless and partially you have the hub service. So you are having the hub service. So suppose you have multiple hubs, which as mentioned previously. So you have chat application and the within the same application you have a chat component and the dashboard component. So you have two separate hubs for that. So if you are implementing one hub as a hub server and the other is as a serverless, so you can configure the SignalR service to use the classic mode. But the problem is, so if your hub server connection get disconnected, so one of the hubs which you have the hub service gets disconnected with the SignalR, then the client connections will not close. They will think that, hey, I'm a serverless kind of connection, so I didn't need to have a hub server, and they try to do the communication using serverless mode, because the SignalR service doesn't know what hub is for the default mode, what hub is for the serverless mode. So when the default mode kind of hubs get disconnected due to some reason or due to some network problem or something like that, then the clients will act as a serverless. Client will basically act as serverless mode. So then that will be problematic because there's no way to do the communication properly, which you have implemented to do using hub service, but now you don't have a hub server and it doesn't support the serverless. So that's the basic thing in this SignalR service mode. So I can show you it in the SignalR resource. So this is a SignalR resource. So create it, and in the settings you can just configure your service mode using whether it's a default or serverless or classic. So in the information, it's saying that switch on serverless mode if your application doesn't have backend server. Basically, you are running serverless, and this configuration change take up to 30 seconds to effect on the implementation. Okay, so that's about it. Okay, so yes, moving on. Okay, yes. So okay, so now I have come to the demonstration part. So I have prepared two separate demonstrations. So the first one is the sample chat application, and second I'll show you how serverless SignalR works with a serverless application. So for the first demonstration, so I'd like to share my code. Okay, so
Tarindu, when you say serverless application, are these for things like Azure function projects which wants to connect with SignalR?
Yes, basically yes. So you Azure, if you have Azure function project, yes, it's not continuously running. Basically, it's run on demand. So in that case, yes. Okay, but in security, we have some cool implementation with the SignalR. So if Hiran is there, he can remember, and Chinti also. So we have that as a separate serverless. We have a separate serverless implementation for the SignalR part separately, rather than going with the normal web server for the other with the other functionalities. So because it's kind of easy with the implementation, I'll come back to that. So when I demonstrate the serverless implementation. Okay, so guys, so actually this is the one of the samples available from the Azure SignalR samples given by the Microsoft. So I have just for this simple demonstration, I just use that. I'm just going to use that sample. So this is going to be a just normal MVC project. So in the startup, you just have to configure the SignalR to run in the SignalR service. So this is how you can configure it, and you can just give you a connection string basically on the as a setting. So I just copy pasted it because anyway I'm going to delete my resource after this. So okay, so this is the main point of the SignalR implementation. So this is the hub which I mentioned previously. Okay, so this hub, so I have only one hub in this application. So this hub is basically implements and exports the methods to be invoked by the clients. So there are two methods, which is the broadcast message and the other one is the echoing. So broadcast message is going to send a message to each and every client which is connected with this service, and the echo function is going to basically echo the message to the same user again, so without delivering it to the other users. So how it has been achieved using this hubs provide this clients all send mechanism, and clients the specific client, so which is the same client which is going to be communicated. So it's a kind of context client ID and send. And basically the send method accepts three parameters. So these are not three parameters. The first parameter is the most important thing. So this parameter is the actual function name which is going to be invoked in the client side. So suppose one client has connected this server and just send a message by invoking this broadcast message message function, and then what this server is going to do, this hub is going to do is, so this hub will invoke all the connections, not the other, all the connections, all the connected clients broadcast message method. So if you can remember, I mentioned at the beginning of the presentation, so SignalR is going to work by invoking the other components function. So basically other hubs function. So from the client side, client will invoke this function, and from the client, it's saying that you need to invoke this particular function in the client. So I will show you in the client. Okay. So when client is going to send the message, so client is going to invoke the broadcast message on the server side hub. So I will show you how it works. So I'll just run it. Let's get started. That's how it has been implemented. So you need to enter a name. So for the first user, I'm entering test1, and for the second one, I will say it's user2. Okay, user2 has joined, but not the user1. Okay, let me refresh this again. Test1. Okay, okay. Now the test one, both the users are joined with the SignalR service. So I can just broadcast message. Okay, so I have sent this message from this client to this client using the SignalR service, and I can just echo a message to myself, only myself. So just it's going to invoke only my it's going to just to show it to myself, not to the other clients. So to show you, actually it's not going to work if you change the name of the hubs methods. So I will just change this echo method to echo 1, and without changing it on here. So basically now the client is going to invoke the echo method, but our hub server is not going to have echo method. It's having echo 1 method. So I will show you it. Okay, so then I will just do a broadcast to show you that has not been affected. Okay, so then I will do a echo. Okay, so there's nothing happened because this client is going to invoke the echo 1 method, but sorry, this client is going to invoke the echo method, but hub doesn't have echo method, so it just have echo 1 method. So just to prove you that, so I can just change it to echo 1 here, and so I'm not going to change any of the client's functions which is getting invoked by the server, so that's why I'm not going to change it here. So only the server functions and the server function name which is going to invoke from the client. So how it's so just okay, 1 and 2. Okay, 2 and I both joined. So then I will again send to all, and I just do echo to me. Okay, so did I change this one? Go 1, go 1, same. Okay, just I'll rerun it again. Should work. So clicking this one. So, 3 joined. Okay, now I am having 3 clients. Okay, no worries. Okay, it's visible in each and every one. Okay. So it's not big. Okay, so did I change the correct one? Okay, so the connection call to the echo method in the hub. So it's the same one. Echo 1. Previously it worked, yeah. Somehow. Okay, it's not working. Let's see that. I am doing this one. Let's see. Okay. I think, yes, I might have not refreshed the correct one. So, okay, so this is the new client. Okay, so now the echo functionality is working, even though I have changed the name to echo1. So since I changed the name of the hub method, so I just need to change it on the target function name from the client. So before moving to the next one, so I'll just quickly show you how it's this connection works. So basically how this get connected. So okay, so SignalR, this JavaScript clients are available, are provided with the Azure SignalR documentation. So you can just go through and find out the clients available for the JavaScript and the TypeScript also. So it's going to build the connection using this URL. So here, this URL is going to have our hub name because our hub is the chat hub. So we have configured it here. Yes, here. So our hub name is the chat. So basically, so this is the endpoint mapping in the normal MEC application. So we have integrated the chat sample hub. So when you have a hub, so this is our hub, and with that, this is going to do the connection. So now it has connected, and on connected, it's going to broadcast the connected message. So that's why we could see the connected information in each and every client. And on connection also, this is going to this, and also we need to bind the other message to this hub, client side hub. So there is this broadcast message function and the echo message function in the client side. So we need to bind that to the connection. So that's how it can be invoked via the SignalR using this hub. Okay, so that's about this small sample about the normal SignalR. So then I'll move to the next demonstration about the serverless implementation. So I'll quickly show you the implementation. So okay, so okay, so I have just used one file to create all the functions. So if you can remember, as previously mentioned, so there's going to be this negotiate function. So it's going to just send the URL and the SaaS token, which is going to be used by the client in order to connect to the SignalR resource, SignalR service. So as I mentioned previously, it's going to be very easy and less code when you are doing implementation with the SignalR serverless, because Azure functions support this binding concept. So Azure functions also support the SignalR bindings. So because of that, you don't need to implement a lot of codes in order to work with the SignalR. So first, so I just show you this negotiate function. So to explain it a little bit. So this negotiate function is a HTTP triggered function. So when this is running, I need to do a HTTP call, and the HTTP call, I'm sending the user ID inside one of the headers. So I just need to configure and differentiate my connections. That's why I'm using user ID to differentiate. And with the SignalR binding, so this is going to be an output binding to the Azure function. So it just does the work to get all the connection information, which is also given using this SignalR connection string. So it just connect to the SignalR service. So I have created another resource in order to just to demonstrate the serverless mode, because I don't trust that mode changing thing, because sometimes I have experienced a few issues, even though it takes only 30 seconds, but it has taken more than 30 seconds for me. So that's what I have created another resource for this one. And this will have this also the broadcast function. So this is going to broadcast the message to each and every client connected to this service. So again, there's this SignalR binding. So this is going to be a little bit different. So it's a so the binding is going to be the SignalR message. So Azure function binding support this asynchronous binding using this async collector. So what I'm going to do is just create this SignalR message which I need to send, and SignalR binding will works on the how to send it and all those things. So it's a very small code. So okay, and other than this normal message sending, I have implemented this management concept in this sample, which is available with this Azure SignalR service. So basically, when you have users, you can group few users into one group, into basically groups. So that grouping is happen using this particular HTTP trigger function. So I'm using this SignalR group action binding in order to do the grouping. So what I have done is I am sending the both user ID the group ID. So then it will be grouped under this group. So basically, I can add a user to a particular group using this function. And then I have implemented this group message. So what it does is it just send a message to the particular group. So I have implemented it in a way like that, and just a SignalR binding. So this will just communicate to the SignalR service using this binding. So this is the same as the broadcast message binding, but if you can see the message bodies, not the message, the SignalR message is a little bit different, because here I don't have specified any group here, so it's going to be all the users. So, and if you want, I think you can yes, you can configure any user. If you want to send it to a particular user, you can just configure it here. So for this one, I have configured the group ID, and this target is the method which I'm going to invoke on the client. So then I should have a method called new message in the client side. So let me show you that. So this is my client code. So this has been written using React. So it just since it was easy to me using React, so I just okay. So this is the SignalR service. So I have implemented this new message method. So it will get invoked because I have binding to the SignalR connection using this. Okay, so just to show you a few things, when I connect to the SignalR service, it's going to connect to my Azure function. So at the same time, I just run it. So it's going to be easy for us. So connect to and do the negotiate call. Okay, it's connected. Okay, this one. So calling to this negotiation endpoint, and it will get all the necessary information like the SignalR URL and the access token, and then it will call to the actual SignalR service using
those information like here. So basically, so using this SignalR hub connection builder. So with the URL, so this URL include the hub which I'm going to work on. So it's already mentioned in our bindings. So this will include that information. So in this way also you can have separate hubs, different hubs, multiple hubs if you want. So then you have to figure out a way to expose those hubs using negotiation call in order to build the communication between the client and the SignalR service. So and the add to group functionality. So it's going to be a simple call to that group endpoint with the user ID and group ID, and send to group again to group ID to the message, and the broadcast, just a broadcast endpoint to the message. So these are the functions I'm having. So broadcast, group message, and the negotiate. So then I'll quickly run this one. Okay, it was not good in the large view, so just I did it purposefully because I need to run multiple clients in order to demonstrate. It's not good. Okay. And the next one. Okay, and I need the other one. Should be this one somewhere like this. No worries. Okay, I'll configure it now. Right now. Okay, so I have 4 clients. So I just connect using some user IDs. So the first I'll connect it is the user ID 1 and 2, and then 3 and 4. Okay, so now I have connected to the SignalR service, and then now I'm going to add these users to a group. So I will add this first and second users to the group number 1, and third and fourth users to the group number 2. Okay, so now I have added those users. Now I will just send a message to all the users. Okay, so as you can see, so I just have broadcast message to all the users. Then I'll just hi all in my team, my group. So I'm just sending message to only to my group clients, my group. So as you can see, the clients in the group 2 doesn't get the message, doesn't receive it. So in a way, so okay, I can hi all to all the clients and hi all to my group 2. So it's going to communicate to the correct group. So previously we had some when I was doing implementation with the Security, so I found out that some of the issues with this grouping concept, but seems like it's not happening now. So it's good. So probably I need, yeah, can talk with Hiran about that further. Yeah. Yes. So that's about the demonstration. So since it's very fast, so I just need to show you some other things like this SignalR pricing. So it's available like this. So basically there are 2 tiers at the moment. So the free tier and the standard tier. So free tier only supports maximum 20 parallel connections, concurrent connections, and the standard tier supports 1000 connections, and there are limitations on the message per unit, and only 1 unit available in the free tier, and standard unit you can buy on a maximum 100 units. And if you exceed the daily quota of messages per unit, you can even purchase messages quotas. Okay, so it's very cheap. So $1 per billion messages. So yes. Okay, guys. So that's it. Do you have any questions? So, okay, I couldn't see any questions on the question tool also. So do you have any questions? You can just raise your voice now and ask. Okay, guys. So silence means that you don't have any questions. So then I can conclude the session. Thank you very much for your participation.